somewhere in your notebook or something. And remember that pre-calculus has AP pre-calculus has 4 units. Only the first 3 are tested. So I have gone through the 4th unit and just picked some stuff. We have what, 3 days or something? We're not going to do it, but I picked some things that we're going to get started on. All right, so let me get attendance taken. You're getting your paper out. And the first thing we're going to do is this problem right here. All right, so everybody can just do this without me. I want you to do this problem right here. You're just going to boil that out. And you're going to tell me what you get.
Think about it, right? Just think about it real quick. You put in 5 or 12 divided by 3, you get 9, or at least 1. And then you can get 1 in this area, across, which is your answer, right? You put 5 or 4 times 3, which is there, right? Or no, that's right there. So how'd you...
Boiling this out for me, please.
Right.
One's here. And it's not.
I'm the only teacher here.
All right, what did you get when you boiled this?
It's so wealthy right now.
Okay, guys, come on, let's engage your brains. This should not be like a challenge for you. What's I squared? -1. So this is 5 plus 12i. Right? Now, what if I wanted to take it to the 6th power? Could I do it? Absolutely, but it's going to take a while, right? To do it this way, it's going to take a while. So there is a very kind of famous theorem that allows you to raise complex numbers to powers. This is a complex number. Now, in order for the theorem to work though, the number has to be in polar form. Well, we know what that means. That means we need R and theta. So, I'm going to go ahead and I'm going to change this number. I'm not doing the 6th part yet, I'm just doing this. I'm going to change this number into polar form. So, 3 plus 2i looks like this. This, which is R, is the square root of 13. And then theta, we're doing a separate sheet of paper because this is numerical. So we'll do second tangent, 2/3, 7 degrees, so we get back to the radius. And I get 0.588. Since that angle is in quadrant 1, second tangent, 2/3, that is the angle, that's theta. So R is root 13, so I have root 13 cosine 0.588 plus I root 13 sine 0.588. This is the polar form. This we talked about, this is supposed to be in do that problem with the law. Now, when it's only squared, I probably would do this, but I want you to see that it really does work. So now we're gonna do this problem with the law. So what is the first thing we have to do? Change it into its lower form. Well, we already did that. It's the same number. So we have root 13. I'm gonna use the abbreviation. CIS 0.588. What do you think that CIS stands for? Cosine cosine. So instead of writing the whole thing out, it's fine. It's fine. This is what the fuller form looks like. But this is how we sometimes abbreviate it, especially in a couple minutes when we're having to write a whole bunch of them. We'll abbreviate it. Okay, so this is our number. Now I'm going to raise it to the second power. What does the law say to do? Take the radius to the second power. Well, what's root 13 squared? And then multiply the angle times the power. So that 0.588 times 2 is 1.176. Now, if all this works, and right now you're just thinking about word for it, if all this works, when I change this into rectangular form, it's going to be that. So in other words, if I take R cosine 1.176, I'm going to get 5. Now, it isn't going to be exactly 5 because I rounded off. It's going to be close to 5. Let's see. 13 cosine 1.176. Oh my gosh. 5.00006. And then what's going to happen when I take 13 sine 1.176? I get 11.999997. All right. Now, in a minute, I mean, if you're feeling like, boy, this is so cool, just give me a minute. Let's practice one more and make sure that we understand how the law works. Remember, you take the radius to the power and you multiply the angle times the power. That's how it works. So if we have a number like negative 2, let's do this is negative 3 plus 4i, and we're going to raise it to the fourth power. 2, so I have a quadrant 2 angle. No, this angle right here is too big. That's too big. All the way around is 2 pi. And what's 2 pi? 6.28, yeah. So we gotta shrink this down. This is too big. This is like having a number that's like 9 pi over 4. We don't do that. We shrink it. And how do we shrink it? Subtract 2 pi. So this is what comes out. But the actual answer would need to be 625 cosine of sine 2.57. That is the polar form answer. The problem, though, was in rectangular form, so we're going to answer it that way. So now I need to change this back into x plus yi.
So I just entered it into my calculator, and it was the same answer for like the 8.81 and the 2.571 for the x. Like 6.5 cosine 8.856 is the same as the
Yeah, because these are the same angle.
yeah. Wow. I just
Yeah, so it's like when we have to find the cosine of 9 pi over 4. 9 pi over 4 is not on our unit circle because this is more than one spiral. So where do we look for 9 pi over 4?
it's in the same spot as
At 1 pi over 4. These are the same. They're in the same spot. So when you evaluate either one of these, it's going to be the same. But the rules, it's kind of like we never write 2/4. We always write 1/2. But they're the same number. We never have an angle bigger than 3/16. Yeah. So what did you get when you did 625 cosine either one of those?
526.5
526.5.
like 998.
So that's just 6. And then, what did you get when you did the sine? Okay, so you do 625 sine.
336.628.
And that one gets the I. The I goes with the Y, which is the sine. There you go. Okay? So, we took our original number, we changed it into polar form, raised it to the power, and we did that by taking 5 to the power, angle times the power, cleaned up anything that needed cleaned up, and then changed it back into rectangular form by remembering that x equals r cosine and y equals r sine. And this is r, and this is theta. Okay, you ready to try one on your own? Next will be exciting, I promise. Here's the one you're gonna try on your own. Let's do -1 minus root 3i to the 8th power. And here's the kicker. Do it without a calculator. You can do this one without a calculator. Think about it for a second.
Oh, wait. I see it. I think I see it.
Yeah, I see it too. It's right there.
What? The radius is 2. Now, I took away your calculator. But if you had a calculator, wouldn't you be saying, I want the angle that has a tangent of root 3? Whoa, we know that. We know that. What is the angle whose tangent is root 3? Pi over 3, right? Except it's in quadrant 4, so it's the pi over 3 in quadrant 4 that's way too big. Way too big. So, let's see, let's shrink that down.
Say it again.
What is that the same as? 2 pi over 3? Because you took away 30 thirds, which is 10, and 10 pi is 5 revolutions. So you just took out 5 revolutions. All right, this is our answer. That's your answer in polar form. Now we're gonna change, I hope your mom watches this. Now we're going to
I will make her.
change it back to rectangular form. All right? So what is the cosine of 2 pi over 3? Cosine 2 pi over 3.
Negative 1/2. Sorry. I was like, it's right there.
So we're gonna get, negative 128. What is the sine of 2 pi over 3? 3 over 2. So that's gonna be 128 root 3 pi. Now, here is where things get exciting. This is where it came up in, and I don't remember which class it was, either linear algebra or differential equations, one of them. It came up that they had to do something like, 2 minus 2i, the 6 roots of that. Now, have you ever thought about this before? Taking the root, square root, cube root, whatever, taking the root of an imaginary number. You want to hear the really good news? The law works with every exponent. So what is a 6th root? The 6th root is a 1/6 power. And the law works with negatives, fractions, any kind of power. So we're gonna take 2 minus 2r to the 1/6 power. So what is the first thing we do? Polar form. So here we go. 2 minus 2r. This is gonna be 2 root 2, which for the time being, you'll see why in a second. I'm gonna leave it as the square root of 8. And maybe you can see why. what would you tell me? Plus or minus 3. Every number has 2 unique square roots. Right? Even if it's not a perfect square, the square root of 5 is plus or minus root 5. Every number has 3 unique cube roots. One of them is real, the other 2 are imaginary. Every number has 6 sixth roots. So there are actually 6 answers to this problem. You have found the first one. And the good news is, that's the only one that really requires any work. Alright, how do we find it? Well, here's the happy news. If I graph the 6 answers on my circle, the first one would be at 7 pi over 24, whatever that is. Those 6 numbers around my circle would be evenly spaced. Well, wait a minute. If there's 6 numbers evenly spaced, how far apart are they? Pi over 3. So if the first one is at 7/24, the next one is going to be at 1/3 pi later. So that's going to be like 15/24. I'll reduce that in a second. But are you with me? And then where's the next one going to be? Another 8/24. And another 8/24. And another 8/24. I'll reduce this one too. And finally, my last one is at, what is that? 47/24. Now, what if I got carried away and did an extra one? What if I didn't have enough numbers, I wasn't counting, and I did an extra one? Well, that would be at 55/24, which is exactly the same as 7/24, so it loops back around. So when I said every number had 6 unique 6 roots, that's true. Every number has infinitely many 6 roots. They just keep cycling back over top of each other. The radius stays the same. So here's my circle. Here's 7/24. Here they are. They're all on the same circle. They're just moving around that angle in the spokes of the wheel. There are 6 of them. Okay? Alright, so let's try one more and we'll do something different. Let's have you find the 4th roots of 1. addition. And since I'm starting at 0, just pi over 2. The next one will be pi. And the last unique one will be 3 pi over 2. Let's put these into rectangular form. Okay? What's the cosine and sine of 0? Isn't that just 1 and 0? So 1 cosine 0 would be 1, and 1 sine 0 would be 0. Does that make sense? Kids, we're finding the fourth roots of 1. Isn't 1 a fourth root of 1? Yeah, yeah. What's this one now? 0 plus 1i. There you go. There you go. What's this one? Negative 1 plus 0i. Negative 1. If you were walking down the hall and I said, hey, what are the fourth roots of 1? You would say 1 and negative 1 for sure, wouldn't you? Because there's 2 more. There's these imaginary ones. Yep, there you go. Just so you see how all the pieces fit together. If you took this equation and solved it like you did back when you were a kid, you factor it like this, right? This says x squared equals negative 1, so x is plus or minus pi. This one says x squared equals 1, so x is plus or minus 1. I'm telling you, it's all fits together, it's all the same thing. All right, so enough of that. Know it, we'll have a quiz over at some point. Know it. All right, let's get out our notes now that I gave you. We're gonna talk a little bit about, oh, this is all so cool. I don't even know. I don't even know where this is. Okay. So let's just start with the first one. I may be doing some skipping around because this is so much. We're gonna write the pyramid equations of a line through negative 2, 3, and 6. You already know how to write the Cartesian equation. Like y equals mx plus b. You already know how to do that. What would be your first step? If you just said write the equation of a line. First thing and adding multiples, and I always use the letter T, the variable T, of that motion. Now think about that for a second. Start at one of your points, I just randomly picked this one. And from that point, move 1, 5, 3. So over 5 up 3, one time. Or maybe 2 times. Or maybe negative 1 time. So if I move multiples of that motion, I will generate the whole line. Does that make sense to you? This is called the vector form of a line. It is exactly like we said. Because what's this? The original point. One of them, you can use either one. And what's this? The slope. Just be careful when you write your slope. It's x comma y. Right? So this is the vector form of a line. If I break that apart, I get my parametric equations. X equals -2 plus guess what's gonna happen when you do the bottom equation? You're gonna get the bottom half. So if we graph them together, we've got both equations together, we're gonna get our circle. The circle is not a function, but the individual pieces are functions. They're called the implicit functions.
Mine, there's like a gap.
I know, I don't understand it. Google it, it always happens. They don't connect, I'm not sure why. They should.
Maybe to show that it's different.
Yeah.
What is like why is the algebra and stuff so obsessed with having functions? Like what's the importance of having it be a function?
Well, remember what functions are. Every x has only one. So equate to get one answer to our problems. That's what functions do.
What about like zeros? Then you got a lot of answers for zeros.
Yeah. But the zeros of a function are different. Yeah, I see what you're saying. I mean, if I plug in 4,
Yeah.
I get one answer.
Yeah.
It might be 0, but 4 only gives me one answer. The 0 is the output variable, and that can repeat. So 4 can give me 0, 8 can give me 0, 10 can give me 0. If 4 gives me 0, that's all it is. So the input produces one output. With this equation, an input could produce 2 outputs. And that just makes it, you're like problems that is a little odd. All right, let's look at the next one. The next one is a little bit tricky because, well, you tell me, why is this one a little bit tricky?
Because you can't solve for y.
You gotta solve for y. In order for this to work, you have to solve for y. Now, you know, especially in a very abbreviated lesson, I'm not even giving you a problem that's not doable. How are we gonna get out of this? We have to solve for y. What do you notice?
Y squared
Factors. Factors. How does this right here factor? Y minus x. Squared? Now, how many y's do I have in Olympic? Do I have 2 different y's, and that was the problem? How many y's do I have now? One. That's just both sides. So y minus x is going to equal plus or minus 2. So y is going to equal x plus 2 or x minus 2. What do we have? What are these? These are lines, and no. They're actually parallel, aren't they? Aren't these parallel lines? Yeah, so the graph of that equation, funky as it looks, is simply a couple of parallel lines. All right, try C. Try C on your own. With your partner.
With my partner. So, on my own, you mean? It's like the high school. It's also
pieces all come together. This is the equation of a circle centered at 0, -1, with a radius of 2. Look at your picture. Isn't it centered at 0, -1, with a radius of 2? Oh, this makes me so happy. Everything comes together so well. All right, anybody have a question about that? We're moving on. Part 4. Moving on to parabolas. We're going to spend a few minutes with each of the conic sections, parabolas, ellipse, and hyperbola. You did this last year. Hopefully you remember something about a parabola. I don't know how Mrs. Luddington approached the parabolas last year. This would be the function form of the parabola. Y equals. Usually in pre-calculus, you look at the parabolas in this form. It makes no difference for our purposes which way you look at it. Somehow, first of all, do you agree these are the same equation? Somehow, we have to be able to find the vertex, the focus, the directrix, and the focal width. Do these words sound familiar to you? That's the only one that sounds familiar. Yeah. Focus and directrix, cross out those sides here. Vertex is between. All right, so let's go over this so that you have some understanding of what it is we're doing, guys. I know it's a lot. We are going to have a quiz over this in a little bit, so you can pay attention. Let's start with the definition of the parabola. Yes, that equation is familiar to you. I mean, you've seen the equation of parabola. It's quadratic. These are parabolas. A parabola is the set of points in a plane equidistant from a given point in a given line. That's the definition of a parabola. That's what a parabola is. So if I have some given point and some given line, the points that are the same distance, like this one right here, would be the same distance from the point and the line. So with this one, so with this one, so with this one, so with this one, that makes a parabola. This point is of course the vertex. This point is called the focus, and this line is called the directrix. The focal width, as you probably imagine, is the width of the parabola through the focus. Obviously, the bigger that number is, the fatter your parabola is. Okay? Now, here is the beauty of having your equation in this form. gives us the focus and all, everything we need. This one gives me the vortex. But this one really gives me everything. So, here's how this works. This parabola has a vertex at -1, comma, -3. So look here, this is -1, -4. So this is then x -1, then it would be +1. Okay, that's your vertex. The focus and the directrix, the location of them, depend on which way your parabola opens. This is an x-squared parabola. What do we know about x-squared? Those are our quadratics. Y equals x squared. Up or down, depending on the sign of this coefficient. That's a positive coefficient. So this parabola opens up. Because it opens up, its focus is going to be inside of it. They open around their focus. And they open away from their directrix. The focus, you know what this is called. This dashed line I just drew is called the axis of symmetry. The focus is always on the axis of symmetry. And the directrix will be perpendicular to it. Always. Now, I know that I gotta figure out what the coordinates is. So I know I need to go straight up and mount. That amount, for some reason, I don't Google it, it's called P. And in every equation of every parabola, this is reliable, believe it or not, every equation of every parabola, this number right here, that coefficient, is 4p. Every time. It's 4p. So if 4p is 4, then p must be what? So I'm going to start right here and I'm going to go up 1. So here is my focus. So straight up 1 is going to be at -1, -3. And remember the whole equidistant thing? If I go up 1 for my focus, I'm going to go down 1. This is a line. If I come down 1, won't this line be y equals -5? And then the coolness doesn't stop here. This number right here, which is so important, that guy is 4p every time. The focal width is 4p. So the focal width for this parabola is 4. If we were going to graph it more accurately, I just put it up there. If we were going to graph it more accurately, you would start at your focus and count forward 2 and backward 2. And that would tell you exactly how wide your parabola was. Alright? That's a lot. I'm really trying to do this whole way. So let's try another one. Let's try it here. Problem B. Tell me anything you know about this parabola already. Tell if 4P is an 8, then P is 1/32nd. So I'm gonna start here and come forward 1/32nd. Where am I gonna be?
-2 plus 1/32nd.
So -1 and 31/32, comma 3. And if I went forward a 32nd with focus, I'm gonna come back a 32nd, and this is an equation now, not a point, this is an equation, it's a reference, it's a line. X equals -2 and 1/32. And what's my focal width? My picture isn't right, but what's my focal width? 1/8. So if I had graphed this thing correctly, it would be very, very smooth. Right, very nice.
This is for,
Yes.
for the focal width, can you just write 1/8?
Now, if this number had been negative, that would open the parabola in the other direction, but the focal width would still be 1/8. Still be 1/8. All right, let's take a look at the equation we just did, this guy right here. And let's write the implicit functions and graph it on our calculator. No, boys and girls, your calculator ain't gonna graph this because it's not a function. So the only way you're gonna get it graphed is to do the implicit functions. So let's do that. We're almost done. So let's solve for y. We're doing the same problem now. We're gonna graph it on our calculator, so we're finding the implicit equations, implicit functions. Plus, 2 what's the direction or the definition of a parabola? Equidistant. So your vertex is in here someplace. -3 to 11. What's the midpoint, the halfway point? 4. And the y is going to be the same. So it's 4, 4. The vertex will be right in line here. All right, tell me what else you know. Matthew?
It's a y squared.
It's got to open which way, Matthew? Left. It's got to open to the left, and Matthew says if it's opening to the left, it's y squared and negative. And I already know what goes in the parentheses. It's going to be -4, -4. Because that was my vertex. Only thing I need is that coefficient. What do you think about that? Then it's saying E is 7. Would you agree with that? Vortex focus 7. And if P is 7, then this number, which is 4P, is 21. All right, get out the other paper I gave you. Did I not give, did I give you the only one? Oh, give me another one.
Give a sample of
All right, so this guy has practice.
We need to bring any of the practice samples. If I were you, I would like recycle it.
Put him, I put him in a frame somewhere, hang him on my wall. All right, did everybody get the practice? Okay, notice. Notice the first, see how they go together pretty much the problems that we have been doing? So we are going, we're gonna go all the way. Okay, so we're gonna do 1, 2, and 3. And then in 4, we are going to do C. So you're doing 1, 2, 3, and then 4C. Alright, you can do it right on this paper or on other paper. Next time we come together, we'll check those answers, and then we'll continue following through our pattern. The way I envision this, we're gonna just keep going. We're gonna have a quiz over this on exam day, last half of exam. First half will be reviewing and talking. The quiz will not take that. I do not see you tomorrow.